Hello students, today we're going to learn section 4.1, angles and their measures. Now, to measure an angle, we have two different units. One is called the degree unit, which you did in geometry, and also in geometry you went over radians. So degree and radians are two different units to measure an angle. Whenever you see this symbol, this is the Greek letter theta. So again, this is the Greek letter theta. When measuring angles, we usually use theta as our unknown angle versus what you're used to seeing in algebra, x, y, and z. So we're using Greek letters usually when we discuss trigonometry. If you remember this from geometry, this is our right angle. So the right angle we know is equal to 90 degrees. So theta is equal to 90 degrees, or the same right angle is equivalent to pi over 2 radians. So again, two different units to measure the same angle, degrees and radians. In your homework, you're going to see DMS. DMS means degrees with the little circle notation above the number, minutes, 1/mark, seconds, 2/marks. So DMS means degrees, minutes, and seconds. In example 1, we're going to convert DMS to decimal form. So here is our DMS. 42 degrees, 24 minutes, 36 seconds. We're going to convert this to decimal form. So to do that, the first thing we're going to do is we are going to convert the 24 minutes into degrees. So 24 minutes, there's 1 degree per 60 minutes. 1 degree per 60 minutes. So the reason why I wrote the ratio is because I know the minutes are going to reduce to 1. So now you have 24 over 60, 24 over 60, and then the degree mark. 24 over 60 reduces to 0.40 degrees. Bring down the 42, 24 minutes is now 0.40 degrees. Next thing we're going to do is we're going to now convert 36 seconds to degrees. So 1 degree is 3600 seconds. So again, the reason why I wrote the ratio this way is so we can reduce the seconds, reduce the unit out. So now we're just in degrees. This is now 3600 over 36 over 3600. This reduces to 0.001. So we add 42 plus our 0.040 plus our 0.001. So this is now decimal form, 42.41 degrees. So this DMS is now in decimal form. Example 2. We're going to convert degrees to degrees, minutes, seconds. We're going to go in the other direction. So we're going to start off with 37.425 degrees. We do not have to worry about the 37 because this is already degrees. That's the first unit, degrees. Now we have to convert 0.425 into minutes and seconds. So you're going to take 0.425 and you're going to multiply times 60 minutes per 1 degree. Remember, that was the ratio. For every 1 degree, there's 60 minutes. The reason why I wrote the ratio this way, so the degree units will reduce to 1. Now we're left with minutes, so 0.425 times 60 minutes is equal to 25.5 minutes. Next, we're going to convert the 0.5 minutes into seconds. So we know that for every 1 minute, we want seconds now. So for every 1 minute, there's 60 seconds. Or you can say 60 seconds is equivalent to 1 minute. So now we can reduce the minutes out and we're just going to be left with seconds. So that's 30 seconds. So here's our minutes, here's our seconds, here's our degree. So now we converted degrees to our degree, minutes, seconds. Alright, next example. We're going to convert degrees to radians and radians to degrees. So what we're going to do first is we're going to go over how to convert radians to degrees. To do that, you're going to write the given radian and you're going to multiply by this ratio. 180 degrees is equivalent to pi radians. Now later on in the lesson, we are not going to have to write radians, okay? Because radians is equivalent, if you see the symbol pi, that means it's in radian mode. So what's going to happen is when we take the given radians times the degree over pi radians, the radians reduce, so now you're just left in degrees. Okay. To convert degrees to radians, you're going to take the given degree times pi radian over 180. When you multiply it in this manner, the degree symbol will reduce to 1. Alright. So radians to degrees, given radian, multiplied by 180 over pi radians, the radians will reduce, you're just left with degrees. Degrees to radians, this is going to, you're going to write the given degree times the ratio of pi radians over degree, so now the degrees will reduce. Okay. So here's example 3, convert degrees to radians. Take the given degree, 90 degrees, times, we said degrees to radians, so we're going to use this here, pi radians over 180 degrees. So what you're going to notice is this and this will reduce. 90 over 180, so that's 1 and that's 2. So 90 over 180 is 1 over 2, so we have pi over 2 radians. Now later on in the lesson, it's not necessary to write the word radians. Okay, you could just say pi over 2 and it's understood that you mean radians. Part B. Again, we have to convert degrees to radians, but here we have a minute. So we have to go back and convert minutes to degrees. So that's 30 degrees times 30 minutes times 1 degree over 60 minutes. The minutes units will reduce. So 30 over 60 is 0.5. So 75.5 degrees, we still have to convert to radians. Again, we're going to take the pi radians over 180. And this right here, since we don't have a pi symbol, because I just multiplied everything out, I'm going to use the word radians. So 75.5, the degrees reduces to 1, times pi divided by 180 is approximately 1.3177 radians. So in example 3, we converted degrees to radians, degrees to radians, degrees to radians. So in example 4, we're now going to convert radians to degrees. Okay, so we're going to use this formula here, radians to degrees. So here's a given radian, pi over 4 times 180 over pi. The pi's reduce, the pi radians reduce, so now you're just left with degrees. 180 over 4 is 45 degrees. So you converted radians, which is the given in red, so pi over 4 is equivalent to 45 degrees. Part B, we have 1.3 radians. So again, to convert, we're going to use 180 over pi radians. Well, the radians units are going to reduce, so 1.3 times 180 hit equal divided by pi, and now you're left with degrees, 74.48 degrees. So, and again, example 4, we converted radians to degrees, and we used this conversion. All right, that's it. Have a good day.